Okay, so here we are, part two. I'll try and make this pretty quick and finish up in just less than 5 minutes. Anyway, so in this paper they talk about characteristics of plant population viability analysis in the published literature, and I think it alludes to why we have a relatively modest call for PVAs in plant recovery. So there were 200 PVAs that they found. 23 represented species listed under the U.S. Endangered Species Act, and 28 under UCN red listed species. So most of them aren't those kinds of species. So if you look at the model types out of the 280, most of them were stage or age-based matrix models, and smaller numbers of different kinds of models, as you can see there. I think the telling part of this is the data set length. Of a total of 231 species, 160 or 69% had 5 years or less of data. Another 23% had 6 to 10 years worth of data. So basically less than 10% of the species had more than 11 years of data. Similarly, for the 275 species that had reported on data set size, something on the order of 70% of them had one or two populations, and very few had more populations. So once again, reiterating that fact that few years and few populations is the norm, and that it's very rare to have a model that has enough years and enough populations to really make a robust model. And that relatively few of them do sensitivity and elasticity analysis and or live table response experiments. And we'll talk a bit about adding stochasticity and uncertainty tomorrow in class, and so I won't deal with that here. Okay, so there are a couple of papers that I think are really critical in thinking about PVAs. Miley Neal again, viability in practice by the numbers. How is recovery defined? And so this is again looking at all these recovery plans, and this time Mike Scott is an author on this, so this is that collaboration. Now they're looking at all their 1,173 species with recovery plans, and they say, even if threats are abated, the low abundances required for recovery often preclude a high probability of persistence, and so we're often setting a relatively low bar for recovery. And so the median number of populations required for delisting was 8, and was at or below the historical numbers for 64% of the species, and at or below the number at listing for 37% of species, which is kind of a surprising number, because we think we only list species when they're really at high risk of extinction, and think that we could recover them with continued losses seems absurd. So the median number of individuals is exceeded abundances for 93% of the species. So at least there we're anticipating that species population sizes will increase. But anyway, not particularly strong numbers for recovery. If we're not going to use, all right, so here's Gina Himes-Bohr from Montana State talking about developing those objective and measurable criteria. And remember, this is closely paralleling that whole project management thing where open standards wants objective and measurable criteria for achieving goals. And similarly, we should be thinking about that with endangered species. So these should sound familiar, that she calls for 6 criteria: contain a quantitative threshold with calculable units, you have to be able to measure it, stipulate a time frame over which they must be met, explicitly define a spatial extent to which it applies, specifically identify a sampling procedure that includes sample size and a statistical level of significance, and include a justification that describes the scientific evidence by which the criteria define a species whose extinction risk has been reduced to some specified desirable level. So it's just basically being explicit about setting goals, and that PVAs do that for you, and this is one of the reasons that she in this paper strongly advocates the use of PVAs in recovery planning. And so she talks about population viability assessment, and describes it as a broad set of analytical tools, and describes a lot of variance on population viability, and we'll talk about some of them, not all of them. whereas Shea Wolf in 2015 suggests the 3 R's of recovery: representation, resilience, and redundancy, where they're defining a significant portion of the historical range to mean a full range of ecological settings, although that's a relatively vague term and they don't really define that very carefully. And resiliency of a population are population-specific attributes that increase the long-term persistence in the face of disturbance, and also includes threats abatement and recovery of effective populations. I put the quotes around effective because I have no idea what that means. And also then redundancy, that they have multiple populations in each of these ecological settings to spread extinction risk and increase viability. So that's a big step away from PVAs as a tool to be explicitly used in endangered species recovery. So are PVAs dead? I don't think so. Vortex and Ramus are both, despite the fact that you can do this all now on R, Vortex and Ramus both seem to be alive and well, selling commercial products that help you do a PVA in a variety of different ways. Down the lower left here you have the papers that were published in 2015 on ISI Web of Science. If you search on the terms population viability and Vortex or Ramus, so that these are 6 papers that use one of those 2 software packages. And down the lower right you see that the National Conservation Training Center has a course on population viability analysis 1, implying that they have more than just one, and it's open to Fish and Wildlife Service and Forest Service and other federal resource and National Park Service BLM employees, and I guess not Forest Service, it's Fish and Wildlife, BLM, and National Park Service employees. So that these seem to be still viable concepts for certainly the framework of thinking about viability is an important, fundamental, foundational concept for thinking about populations. And the question is, I think, when you have the resources to have sufficient and robust enough information to invest in a formal PVA that will give you a result that is defensible and robust for the purpose that you're considering. And that will be it. Thanks.